I hope everybody's having a great day today. Um, Today we get to take a look at my second favorite conic section, my favorite being an ellipse. So we're going to hit hyperbolas today. And a hyperbola in some ways is kind of like an inside-out ellipse. So first thing, we are only going to talk about two special types of hyperbolas, kind of like we did with ellipses. We talked about an ellipse that had a vertical major axis and an ellipse that had a horizontal major axis. We're going to talk about hyperbolas that have a vertical axis and hyperbolas with a horizontal axis. A little bit different than an ellipse. We only have one axis, but we do still have two foci, and we'll see how that all works out here in just a little bit. So first thing, what is a hyperbola? Well, I want to speak in terms of how it works in my conic. So here's my really great artwork again. Here's my conic, and we know that, I'm going to draw a couple here. We know that if we have a plane that intersects something like this, we get a parabola because it intersects one of the cones and never comes back out the other side. If it intersects perpendicular to the axis of the cones, we get a circle. If it intersects something like, let's go with green this time, this, where it comes in one side of the cone and out the other side, we have an ellipse. We get that elongated circle. But today, let's get rid of all of those. Or maybe we'll just, might be easier to just draw a new conic. So here's my new conic. And the one that we get to talk about today is called a hyperbola. And a hyperbola occurs when we have a plane that intersects, it's perpendicular to this axis that goes through the center of our two cones. So what it does is it actually intersects both cones, and you get two parts to that. Really rough sketch of what that looks like if we think about kind of turning that to a side view and seeing what that would look like there. We end up with, oops, let me get my pen out instead of my line tool, a top section that looks something like this and a bottom section that looks something like this. And we'll get all the details in here in just a little bit, but that's kind of the intersection that we're going to have with those conics. So what is the definition of a hyperbola? Well, here we go. Consider two foci. So I'm going to go ahead right now, and I'm not going to just say that they're 2 points. We know that, in fact, they are going to be called foci. And we're going to name those F1 and F2, similar to what we did with an ellipse. But this time, instead of taking the distance from a point on the ellipse like we did to the focus and adding that to the distance of the same point to the other focus, this time we're going to subtract those distances. So it's a collection of points in a plane in which all the differences of the distances to the foci remain constant. The constant difference is called the focal constant. Okay, so picture of what that would be. Just 1 point. Here's one focus. Here's two focus. Second focus. Let's call that F1 like we did in our description. F2. Okay, so I've got some point here. Let's just call it D right now. Yeah, we'll call it D. If I measure the distance from focus 1 to D, let's call that capital D for distance, 1. And I measure the distance from F2 to my point D, and let's call that capital D2. I know that D1, because that's longer in this case, minus D2 has to equal my focal constant. And that's always going to be the same once we have it set up for that hyperbola. Works out really great. Now to simplify things a little bit so that we can keep D1 minus D2, we're talking about a distance. Focal distance always has to be positive, so we take the absolute value of these. So that means that even if we take our point from our graph and we swing it over here, and we had D1 and D2, I know it's a little light, but I don't want that to be too much and too distracting there. Still going to be equal to our focal constant because we take the absolute value of those. So that's kind of what's going on with our hyperbola. Now, equation of the hyperbola. So we're going to jump in, we're going to get all the nuts and bolts, all the good stuff out of the way, and then we're going to get in and start playing with some of these. So what I noticed first thing about this equation of a hyperbola is that it looks very similar to the equation of an ellipse. I've got x minus h squared here. I've got a squared underneath. Got y minus k squared in the numerator of the next term. I've got b squared in the denominator. It equals 1. But the big difference I see here is I see this minus in the middle. So that's a big difference between a hyperbola and an ellipse, the equation. Ellipse was plus, hyperbola is minus. Now, because it's minus, the order does matter. So I've actually got two equations for an ellipse. Now you notice here, I've switched around my y and my x. That does make a difference in my graph. I'm going to leave b with the y value, with the y component, and I'm going to leave a with the x component. Makes things a little bit easier for some aspects, makes them a little less nice for others. Now what I notice right here, sorry about that, is I've got this c. C is the distance, going to be again the distance from the center of our conic section to our foci. And this time, if I remember, c squared was a squared minus b squared in an ellipse. In a hyperbola, it's plus. So c squared is a squared plus b squared. It's the opposite of the sign in the equation itself. That's true for both ellipses and conics. My c squared equation, c squared equals, and we're dealing with my a squared and my b squared. Hyperbola minus in the equation, plus when we're finding c. Okay, so I'm going to pause here and I'm going to come back with my second video with some examples.